You're 300,000 kilometers away from Earth, cruising toward the moon on what seems like a routine mission. Then, out of nowhere, a deafening explosion rocks your spacecraft. Warning lights flash, oxygen levels plummet, and suddenly, what was supposed to be another giant leap for mankind turns into a desperate fight for survival. This is the gripping story of Apollo 13, a mission meant to make history on the moon, but instead, it etched its legacy as one of the most incredible survival stories ever told. The Apollo program was NASA's crown jewel in the 1960s. In July 1969, Apollo 11 had achieved the impossible. Neil Armstrong became the first human to set foot on the moon. A few months later, Apollo 12 followed, adding another feather to NASA's cap. But public enthusiasm waned. By the time Apollo 13 was ready to launch in April 1970, moon landings had become, for many, just another mission. The crew, an unexpected change. Apollo 13's crew was led by seasoned astronaut Jim Lovell, with Fred Hayes and Ken Mattingly completing the trio. However, mere days before launch, an unexpected twist changed everything. Mattingly was exposed to German measles, a potentially debilitating illness. NASA made a difficult decision to replace him with Jack Swigert, a capable but less familiar team member. This last-minute change disrupted the crew's chemistry, but they adapted, ready to embark on the 330,000-kilometer journey to the moon. The explosion, when everything went wrong. On April 11, 1970, Apollo 13 launched successfully. For 2 days, the mission proceeded smoothly. The crew recorded a life-arted broadcast, showcasing life aboard the spacecraft. But just after signing off, disaster struck. It began with a routine task, stirring the oxygen tanks. This simple procedure caused a short circuit in one of the tank's fans. The result? A catastrophic explosion that blew apart the service module. Swigert's voice came over the radio. "Houston, we've had a problem. Oxygen levels dropped, electrical systems failed, and the spacecraft's survival became the mission's sole focus." What went wrong? Investigations later revealed that the tank had been damaged before launch. A minor drop during manufacturing weakened its structure. On top of that, an old thermostat, designed for 28 volts, was exposed to 65 volts during testing. The overheating damaged the wiring inside the tank, turning it into a ticking time bomb. When the crew activated the fans, the wires sparked, igniting the oxygen. This wasn't just an accident. It was a cascade of overlooked details, each compounding the last. A race against time. With one oxygen tank destroyed and the other rapidly depleting, the moon landing was no longer an option. The mission shifted to one goal, bringing the astronauts home alive. But survival wasn't guaranteed. The command module, designed to support 3 astronauts for 2 days, was now crippled. The only solution? Use the lunar module as a lifeboat. The lunar module, meant for 2 astronauts for 20 hours, had to sustain 3 people for 4 days. Every system was stretched to its limit. Power was rationed. Lights and heaters were turned off. Temperatures inside the spacecraft dropped below freezing, turning it into a refrigerator. CO2 crisis. A deadly problem. As the crew conserved oxygen, a new danger emerged: carbon dioxide. The lunar module's filters couldn't handle the increased levels of CO2. The astronauts were slowly poisoning themselves with every breath. On Earth, NASA engineers raced against time, devising a solution with what the astronauts had on board: duct tape, plastic bags, and a hose. It was a makeshift filter, and it worked. Against all odds, CO2 levels dropped, buying the crew precious time. Navigating home, precision under pressure. To return to Earth, the spacecraft had to be perfectly aligned. A slight error in trajectory could cause it to burn up in the atmosphere, or skip off it entirely, leaving the crew stranded in space. Without proper navigation systems, Lovell and Hayes used the Sun and Earth as reference points. With Swigert timing the engine burns, they manually corrected their course. It was a delicate dance of skill, precision, and nerves. The final test? Reentry. As Apollo 13 approached Earth, the most critical phase lay ahead: reentry. The command module's heat shield had to endure temperatures of 2,000 degrees Celsius. If it was damaged in the explosion, the crew wouldn't survive. The tension was palpable. During re-entry, communication with the spacecraft is lost for several minutes, a period known as blackout. For Apollo 13, this blackout stretched longer than expected. On Earth, mission control and millions of viewers held their breath. Then, a voice crackled through the radio. "This is Apollo 13. We're home." Cheers erupted. Against all odds, the crew splashed down safely in the Pacific Ocean on April 17, 1970. A successful failure. Apollo 13 never landed on the moon, but it achieved something far greater, showcasing human ingenuity, teamwork, and resilience. It's remembered as NASA's successful failure, a testament to what's possible when survival is on the line. The lessons from Apollo 13 transformed space exploration. NASA revamped its safety protocols, redesigned its oxygen tanks, and improved training for emergencies. This mission wasn't just about survival, it was about learning, adapting, and growing stronger. Apollo 13's story remains one of the most compelling in the history of space exploration. It's a reminder that even in the face of overwhelming odds, the human spirit can prevail. Thank you for joining us on this journey into one of history's most incredible space missions. If you enjoyed this story, make sure to like, subscribe, and share. And stay tuned for more captivating tales of exploration and discovery. Until next time, keep looking up. The stars await.